edition of 3D Printing News Unpeeled, live with yours peels. And today, in our rundown of the 3D printing news, we have an additive manufacturing news as well, of course. We have a number of interesting news items for you. The first one is Cranktown City sinters glass. So Cranktown City is a YouTuber, and he has managed to sinter glass using a fairly basic, hand-built kind of 3D printer. This is notable because, well, there's a lot of people making slightly better FDM or material extrusion printers, often by exactly the same designs, just adding certain trendy items to them. There are now people working on getting the money together to make vat polymerization systems that are much better. But this kind of innovation we don't really see enough of. And this is somebody who's doing something completely out there. Now, as you can see from the bench in front of us, the results are very, very far from perfect, let's say. But the fact that someone is trying to, at home, 3D print glass is the kind of more out there, more exciting stuff I would like to see from the desktop 3D printing community. We're seeing a lot of people refine things, which is nice. But the wilder times than before where people are doing very fundamentally exciting innovations is kind of a little bit behind us. And I would like to see more coming from the desktop that is this radical and new. A lot of people try to print glass using BinderJet, for example. Glassamer prints optical glass. Nobula 3D prints like a glass filament. And we've got LuxExcel, which is optical glass for lighting. And luminaries and things like this. But the applications are enormous for this, and it would be, I think, a source of continued excitement if the desktop community kind of tried to sinter glass. And this is what we're seeing here is that they use just an Atom Stack 20, which is commercially available, kind of simple laser, and and the rest of the printer was, well, it would take you quite a while to build and get it right, but it's a fairly low cost unit as well. So this definitely has a lot of implications and applications, and I think more people should be looking at that. The next is design studio Nagami. Nagami is working with a lot of designers to make 3D printed, quite large scale for us items. They have an ABB robot that extrudes polymer. And the reason I think is notable is because, well, first off, look at just how easy it is that they're doing compared to what a lot of other people are doing. Now, having said that, what they're doing is making beautiful objects using medium format or large format printing. And I don't think a lot of people are making really beautiful things, and they've managed to do this. And I think that needs to be stressed, that more designers need to be active in this business, and their special skills to make these objects truly beautiful and truly very interesting and remarkable. What we're printing right now, and the picture right now is a Ross Lovegrove object. This is another very beautiful, I think, 3D printed item that they made. We can also see here, this is the side view of this Ross Lovegrove thing. We do see like artifacts, and we do see that it's printed. But we don't really, it's hidden away well, and it becomes part of the design very well as well. And that's, of course, if you're working with someone of the caliber of Ross Lovegrove, that's, of course, possible to direct their attentions to making something truly beautiful. Next is the Peeler Chair by Daniel Wildrig, who's done a ton of work in 3D printing with fashion designers, all sorts of people. I think, again, this is another beautiful object. The MAWJ Wow and Riyadh Joka, or Mean collaboration, also made this chair that's very reminiscent of Dirk van der Kooi, who initially, he kind of invented this genre, if you will. He invented this idea of using polymer 3D printing on a robot arm to print design objects and furniture. This is very reminiscent of that, but again, it's a beautiful object. And I think this really points to designers being able to play a role in unlocking a lot of value in 3D printing, and people should really turn to them, and that's what Nagami is really showing us right now. The next thing is a study that came out in Nature Materials by Aijun Huang and Yuman Zhu of Monash University in Australia. And they've been able to, they've been doing something a lot of people have been doing, and that is they're trying to get better microstructure using the 3D printers. What the really exciting thing is, I think, is that they've been able to do this using an improved microstructure, but using quite simple heat treatment on a commercially available heat treatment. So what they did is they took a beta C titanium, and they heat treated at 480 C and 520, and they've got a between 15 to 70% improvement in strength. They report improvements in a lot of factors, but they got tensile strength over 1600 MPa. What they then have created is something it's called nanotwin precipitates. This is quite remarkable. Well, on the one hand, there's lots of people doing really interesting treatments in 3D printing, but what we're seeing here is something that can be commercially applicable in a very, very simple way, and everyone could roll this out using, of course, this beta C type titanium. This begs the question: is there more stuff out there like this? Do we have to look more like this kind of thing, or at this kind of thing? And that, I think, is something that this is, I think, is a very exciting thing, because maybe there are other heat treatment things out there that could make lots of other materials improve dramatically in strength. And the number one thing is actually also from Australia. So it's a good day for Australia. The Universities of New South Wales School of Chemical Engineering has a group of engineers, and one of them is Cyrille Boyer, the other one is Nathaniel Corrigan, the other one Kenny Lee, and they developed a process to print solid-state polymer electrolytes. Now, this is something that a ton of people have been working on, and if this team successfully demonstrates this, which I think they have, this would be quite a coup for them. What's more, as released in Advanced Materials, you can read about it. It's open access, if I remember correctly. These solid-state batteries, or these solid-state battery components, are conductive enough to be interesting, and also strong enough to function as maybe an integrated part of some sort. So we could make a conformal cooling item. We could make a part of a structure that is also a battery, or we could make the battery, also a fastener or something like that. And they can also print in a very, very small object, and then very, very in a very detailed way they report. What's more, these batteries can do several thousand cycles or more, so they could be eminently usable. And on top of that, if you didn't need any more good news today, they can also be made by commercially available DLP printers. So they've managed to make nanoscale ion-conducting channels, and they've embedded this in a rigid cross-link polymer matrix using just a regular off-the-shelf DLP printer. So this means that this could really be a very viable way to make batteries and make battery components, and that is, I think, in and of itself very, very exciting news. And that's it for today. This is another edition of 3D Printing News Unpeeled, and I was yours, Peels. This is coming to you thanks to 3dprint.com, and have a great day.